Today, we're going to be working on our Excel formula book on the decision algorithms. So in our class, we talked about the addition principle when we're talking about having alternatives. So choices, options, things that aren't going to be forced upon us. We can end up adding. So like example 1, it says at a restaurant, you can choose among 8 chicken dishes, 10 beef, 4 seafood, 12 vegetarian. What is the total number of dishes to choose from? So for me, right, I don't like choices, at least not having so many choices. So for our example, I could have either one of the 8 chicken dishes. I could also have one of the 10 beef dishes, one of the 4 seafood, and one of the 12 vegetarian options. In between all of those options, we can add them all up. So I can hit sum or equal sum, and then I can add all of these values up. Oh, where did my 12 go? Oh, that's over there, and that's why. I might put sum over here. So sum of all of these, there we go, close parentheses. So I could have 34 different dishes to choose from. So maybe it's chicken parm, maybe it's eggplant parm, right? A vegetarian one, right? There's so many different options that I could choose from, and I just don't know which one I could choose. So I have 34 different options. Now, if we're talking about the multiplication rule, making a sequence of choices, so in one alternative, we have lots and lots of choices. Instead of adding across, what we would end up doing, and I can just delete all of that, and notice that this one will snap to 0. We can say this is the total number of options. Right? Instead of having them all here, right? What I could say is that, okay, well, perhaps with your sequence of choices where we multiply, something is now being required of us. So instead of just choosing from this kid's meal, okay, cheese pizza or pepperoni or fish sticks, right, and counting up all of these 10 or 11 choices, we now have to make a full-on meal. So perhaps I choose one meal, one side, one drink, and one dessert, right? So now I have to choose one of these meals. And then on top of that, I choose a cheese pizza. And now I have to choose one of these sides. Maybe I choose applesauce, right? And now I have to choose a drink. Now, notice that it's being forced upon me to make a sequence of decisions. Therefore, we end up multiplying here. So at a restaurant, you can choose among 5 appetizers, 34 mains, and 10 desserts. What is the total number of different meals? So for this case, I could have 5 appetizers, and I choose one of them. I then have 34 different main dishes I need to choose from. And then I have 10 desserts of which I need to choose from, right? I can only have one of each. So I could have, and maybe I put it over here, I could have, actually I'll put it right under, is equal to, instead of the sum where we add, we can take the product where we multiply. And I'm going to multiply these choices here. And maybe I want to multiply a little bit more in the future. I should have 17,000 different meal combinations. Maybe one cheese pizza, one fry, one fountain drink, and an ice cream. Or maybe one cheese, maybe a sweet potato, the fountain drink, and still the ice cream. And each different choice that you make in the meal or the side and a drink will then change your alternative or change your choice. So let's step it up just a little bit more. And maybe I scooch this over. I'm going to insert something. And maybe I put that this is the options. So let's change my alternative. It says you walk into an ice cream parlor and find that you can choose between ice cream, of which there are 15 different flavors, and frozen yogurt, of which there are 5 flavors. In addition, you can choose among 3 different sizes of cones for your ice cream or 2 different sizes of cups for your yogurt. You only want a single item. How many different desserts can you choose from? So it's kind of a combination of these 2 ideas put together. So the first thing let's tackle is you now need to walk into the ice cream parlor. And what is the first thing you need to decide? Well, we need to decide, do we want ice cream or do we want frozen yogurt? Well, let's say we wanted some ice cream. Okay, well, how many flavors of ice cream do you now have to, or what is your next choice that you have to do? Well, flavors, right? I kind of gave that away. So you have 15 different flavors of ice cream. Okay, well, pick your favorite flavor. I'm gonna go with chocolate chip. All right, no cookie dough. Love cookie dough. I'm gonna do a cookie dough. Now what do I have to choose? Well, now I have to pick a size. How many sizes do I have? Well, I have 3 different sizes. So that means for my ice cream, and they don't talk about toppings, right? For my ice cream, I must pick the ice cream flavor, and then I must pick the size. So just for ice cream alone, I have 45 different combinations. Let's do it again with your frozen yogurt. So here we have frozen yogurt. We choose a flavor. So one more time, I'm going to pick 5 different flavors. Now I'm going to choose vanilla for my flavor. All right, now I have to pick a size. How many sizes do they have? Well, they only have 2 sizes. So now for the total number of options, we have equals product, and I'm going to multiply between the 2. And again, if I wanted to multiply more, I certainly can. Maybe I do so for the future, but I should get 10. Now, how many options in total do we have? Well, my options up here in total, that was just adding across. That is only if I had just something straight across. Instead, let me sum up these values. And if I had more alternatives, maybe I add up more. So in total, I should get 55 different choices, 45 from ice cream and 10 from frozen yogurt. Let's try it again down here. So an exam is broken up into 2 parts, part A and part B, both of which you are required to do. In part A, you can choose between answering 10 true-false questions and answering 4 multiple choice questions, each of which has 5 answers to choose from. In part B, you can choose between answering 8 true-false questions and answer 5 multiple choice questions, each of which has 4 answers to choose from. How many different collections of answers are possible? We don't care about right answers. We want how many different variety of questions we can have. And notice that your number is very, very, very large. It's 2 million and some odd numbers. So let's focus on part A. Maybe I label this part A. And maybe this, and I'm going to capitalize A. Come on. Why isn't that going through? There we go. Part A. There we go. One more time, and part B. Maybe this one, if you had another alternative, we can label that part C. So first, when we designed this, we said, okay, well, part A, what was in part A? Part A says you can choose between answering 10 true-false questions. So right now, right, for 10 true-false questions, right, let's say question 1, question 2, question 3, question 4, in true false, right? You could either have a true or a false statement. How many options do you have? 2, okay. Question 2, again, true false. How many options do you have? 2. And we can keep going, right? So it's not that we're multiplying 2 times 10, right? We can keep multiplying 2 times 2 times 2 all the way down until you get to the 10th question. So ... and then 2. So when we go to challenge part A, we're taking the total number of options, true, false being just 2. And the number of tosses or the number of questions, I'll say this is number of questions. How many questions are there? Well, there's 10 questions. So for your number of outcomes, we're going to hit equals, always the number of options raised to the number of questions. That has us avoid equals 2 times 2 times 2 times 2 times 2 all the way to 10, right? Instead, we can make it as an exponential. So for part A, we should get 1,204 just for the true false alone. This was just my true false. Now, in our part A, it also says we can have a choice between your multiple choice questions. So I'm going to delete this here for a second. We then have the same thing here. I'm going to just do the same exact copy and paste. We now have multiple choice in part A. So multiple choice, it says we have 4 multiple choice questions. So question 1, question 2, all the way down to question 4. So we have 4 multiple questions, each of which has 5 answers to choose from, either A, B, C, D, or E. So how many options do we have in our first one? 5. And if we did the exact same, right, A, B, C, D, E, if I just copied and paste, that I have now 5 options, 5 options, 5 options. That's 5 multiplied by itself 4 times. So the number of options 5, the number of questions 4, right? So we have 625 total options. Now, is it a choice or is it recommended that we do it? Well, if we have a choice, we get to sum this particular column and this particular column to get 1,649. If it was forced, we would have to multiply, so the product between this option here and this option here. So much, much larger. I might get rid of that one. We don't need it. So we have a choice. So in part A, we have 1,649 total options of your answer key. Let's do it, and that is just for part A alone. Let's take a look at part B. Try it again with part B. It says you can choose between 8 true, false questions. So the total number in a true, false, the total options are 2, either true or false. The number of questions we said is 8. So 2 to the 8th. And then we also have the same exact thing for B, right? We have a choice here. You can choose either between your 8 true false questions or 5 multiple choice questions. So 5 multiple choice questions, each of which has 4 answers to choose from. So 4 options, either A, B, C, or D. And notice that you have 1,024 different options. So again, being a choice, we can do either the 256 or the 1,024. So sum of this and this here. Now, do we have a choice to complete either part A or part B, or is it forced upon us to do all of that? Right? Well, it says you must do these 2 parts. You have to do part A and emphasis on the and part B, meaning that your total number we now have to multiply. So the product between this, comma, and this. If you had a part C, you would then include part C here. Maybe we do it again over here. Here. Maybe you include it down here. Who's to say, right? You can just tack it on. But notice that you have that 2 million response again. Now, they don't all have to be so complicated. As you can see in example 5, you can also make that decision tree here. It says your local Apple store has iPads in 2 sizes, the larger Air and the smaller Mini. The Air is available in blue and green. So you have 2 options for blue or green. Your Mini is available in blue, green, and pink and purple. Pink and purple are happening together. I broke it up as 2 separate colors. How many possibles of iPads are there? Well, you could make the decision tree as to just say, okay, well, your Air, we have a blue Air, or Air, we could be a green Air, and so forth. Again, all you're doing is you are changing the option. And that is going to conclude our session for just setting up your decision algorithm. This part likely will change based on from question to question, meaning that your answer here could vary as well. So just be super careful as far as looking at some of your final answers. I don't like that color. I keep wanting to change it. There we go. You might be included in part C, in which case you have to do a little bit more. And sometimes you might not have an option. So sometimes you might have a requirement. So let's set up your requirement for the future. So again, all you have to do is hit product, between this, comma, this, and do it again, is equal to the product one of, oh, nope, this, comma, and this. In which case, if it's an alternative, you can add these, or if it's a requirement to do all of them, you can go ahead and multiply. But most likely it's going to give you some sort of option. So we can set equal this plus this. So that is the completion of your decision algorithm. Hopefully you find this helpful.